Hello all. Today I'm going to start my sixth session of the machine learning data science tutorial with Python. Today we are going to do the practical implementation of the simple linear regression with Python. So, okay, let's begin. Um, in order to just do it, first of all, I need to show you the data set that we have in which we are going to implement the simple linear regression model. I have a data set over here with the years of experience and with the salary. Based on the years of experience, the salary are changing, which I had actually specified in the previous example of in my previous session, where we were discussing various examples for simple linear regression. So in that, we had discussed about an example for years of experience and salary. Based on the years of experience, there's a change in the salary, and this is based on the market trend. So there's all there's all years of experience and salary data set we are going to implement in a simple linear regression. And the basic steps that we are going to follow is, first of all, let me note down. First of all, we are going to import some packages like NumPy, Pandas, sklearn, that is basically scikit-learn, and matplot. Matplotlib. This is basically for Matplotlib is basically for the graphic purpose. I'll explain you about all these packages once we are doing the practical work. Second, first let me do this first step, importing. So here's my file, simpleregression.py. I've renamed it. First of all, we need to set up the workspace. The workspace, always note that the workspace and the data set that it is present, it should be present in the same folder. So I'll do as save as. You can see over here I've saved as simpleregression.py. Mm, I'll just replace this file, and you can see the salary data set is present over here. So we are going to read this salary data set and do our basically the simple linear regression. I'm just going to replace it. So the first step that we are doing is we need to import NumPy. We need to import pandas, and we need to import matplotlib dot pyplot as plt. So this is the syntax how we need to import the libraries into our Python. You can see the alias name is given over here. This is basically for we don't need to write NumPy in each and every code. We can use this alias instead in order to call those functionalities inside those packages. So currently I'm not importing sklearn because sklearn will be imported later when we are actually creating the classifiers through which we are developing the model. Okay, just let me execute this. For executing in Spider, you need to press as Control Enter, so this gets executed. You have all the packages that has got installed. Okay, now let's go to the second step. In the second step, we are gonna do one more thing. We need to read the data set. So this data set, we need to read it and we need to form as a data frames. Basically, we'll be reading this data set into data frames so that once we take into the data frames, we will be implementing our um, basically we'll be implementing our simple linear regression algorithms. Okay, in this, after reading the data set, after reading the data set, we need to split the data based on independent and dependent variables. Dependent variables are usually given as small y, and independent variables are usually given as x. This basically means that y is your output, and since y is your output, it will always be dependent on this independent variables or the feature variables. So based on these variables, this value will be created. Okay, now let me just show you this salary over here will be our y, that is the dependent variable, and the years of experience will be our feature or independent variables. Cool. So let us implement this two statements that I have written over here. So first of all is reading the data set. In order to read the data set, just let me create a data set variable. For reading the data set, we will be using pandas because pandas libraries usually have those reading functionalities. If it wants to read it from the CSV or Excel file or HTML file or JSON file. So let me just do pd dot. You can see over here from this you can see the all the methods that you can see or how you can read it. There is a read underscore HTML, read underscore JSON, read underscore CSV file. So let me type read on the CSV file because my data set is in on CSV file. Okay, now we need to understand what all parameters that read underscore CSV files X. In order to see how which all parameters the read underscore CSV parameter takes, just click over here and press Control I. After pressing Control I, you'll be seeing all the informations about the read underscore CSV file and what all parameters you'll be requiring. Okay, so for current purpose, like I'll be only using the first part, that is first parameter, that is file path or buffer. So I'll be providing the file part which is present currently in my workspace. All the other parameters we'll be seeing all the other parameters in different kind of examples where we'll be using PDF files or any other files other apart from Excel files and all CXC files. So let me go here. Let me name my file name basically as salary.csv. So this is my file path. You can see over here I have basically my this is my file name that is present into my workspace. So let me execute this. Sorry, it says that file b salary underscore dot csv does not exist. Okay, let me do one thing. Let me just open the file. What's the name of the file? It's salary only. Oh, sorry. First of all, the problem is basically it is not being able to find the salary.csv. So the one thing that we have missed is we have not set our workspace. Always when you program in your Spider programming language, you need to set up your workspace. Set up your workspace means basically now you see that your file is set up over here, simpleregression.py in this machine learning example folders. Okay. Now in order to set this directory as your workspace, you need to do just one thing. Just a second, let me see. You need to just do one thing. You need to just press F5. So once you see do the F5 over here, you see that your current directory will be set up in this machine learning examples folder. You can see over here this simple regression Y folders, and you can also see the path over here because this is the working directory that has been set. So now once you read it, you have got the data frame over here. So this was basically, I did not do it in the initial stage because we need to know about the working directory too. We need always before programming, before starting up, you need to set up the working directory. Once you set up the working directory, then you will be able to read that particular file which is present inside it. So if I show you again, here is the file that is present and here is my programming file which I am programming into. So it is now considering it as a working directory and it is being able to use the salary.csv file. Now I have read the salary.csv file. Now let me show you all the data have come over here. We have basically got the data of years of experience and salary over here. Okay, fine. So on the left hand side and the salary. Now the second step is basically after reading the data set, we need to split the data set based on independent X and dependent variables Y. Now, in order to explain you how this works, I have my data set over here. So the years of experience will become our independent variable, whereas salary will become our dependent variable. So let's see how we'll do that. Now, so it is better that you write comments in your code. Comments to write the comments, you need to just use this hash symbol and you can write the comments. So I'll just write as divide the data set into X and Y. So this will basically give you an information that it is getting divided into an independent variable and a dependent variable. Okay, so let me just take X is equal to, I'm going to use this data set dot. Basically, now this data frame, I'm going to read the first column and the second column. So in the first column, I'm going to actually use it as an independent variable, and the second column will be my, basically my dependent variables, which will be in the y-axis. So in order to read it, you just have to use iLoc. Now, always remember, whenever you are putting, we have to use this iLocation braces. If you are familiar with the um, pandas, there is a functionality called as iLoc, which will be actually helpful for checking out which columns they have to use it as an x-axis and as an y-axis. So inside it, I'll give two parameters, that is colon. Colon basically means, in the first parameter, colon basically means all the rows over here. So all the rows that are present over here, we are considering all the rows in this particular x-axis. Then we need to specify colon minus 1. So first parameter is regarding the rows, and second parameter obviously it will be regarding the columns. So now over here you see that if I put this colon, first colon, right? This first colon specifies all the columns. In the second parameter, the first colon specifies all the columns. From that, you have to do minus 1. Minus 1 means this salary column we are actually dropping it out. So, uh, if we drop out, the only column that is remaining is years of experience. Please do have a note of this. This is very important to understand. In the first, totally in iLocation, we have two parameters. One is for the rows and other is for the column. In the first, we have specified colon, which means we need to take all the rows. And in the second parameter, you see that we have also specified colon. Colon basically means for the first instance, we need to specify, we are taking both the column. From the column, we are doing a minus 1. Basically, we are dropping up the salary column because salary will be going into the y-axis. Cool. So let me just, then I'll just use as dot value so that whatever values we are actually exploring, it will be taking automatically in which format it is, basically in a float. So let me just execute it. Perfect. Now you can see over here, this has got executed successfully. From here, you can see that your X column is basically having all the experiences, and your x-axis is also having this. So this basically is the independent variable that you have set in the x-axis. Now for the y-axis, from the data frame, you know that y-axis is already salary column, so we will be taking this salary part into the y-axis. So just let me do it. Y is equal to dataset dot I log. Again, I have to take the whole columns over here, whole rows over here, sorry, whole rows over here, and I have to specify the column name. Column number is basically 101. So first column, we'll just take it as over here, which will be specifying our salary columns and dot values. Let me just execute it and see what I get as y. Perfect. I've got the salary columns over here, and this is what my dependent variable is, that it will be in the y-axis. Now, this is what you have over here. Mm, So we have completed our third step. Basically, we need to divide the data set into x and y, which is the dependent and the independent variable. So I have my x, y over here. You can see all the arrays that is. Cool. Now let me just go to our next step. In the next step, we will be dividing the complete data set into training, training and test data set. Perfect. So, why we are doing this? Why we are completely dividing the data set into training set and data set, test data set is because through the training data set, we'll be defining our classifier, we'll be creating our classifier, we'll be implementing a particular regression model into it, and we'll be creating a classifier through which that model will be created. So classifier and models. Classifier is not is same as the model. We'll be implementing our linear regression on based on the training data, and on the test data, we'll be actually predicting what are the values for that particular test data. So this fourth step is also simple. Let me show you how we can do it. So let me just give a comment that we are splitting the data based on training and test set. Perfect. Now, in order to implement this, as you know, I think you have heard about this scikit-learn library. So from the scikit-learn library, I'll write slide it as sklearn dot. In the sklearn, we have something called as cross underscore validation. In this cross underscore validation, we are going to import train underscore test underscore split. So what this basically does, this is the package which will actually divide our data frame into some amount of training data and some amount of test data based on the parameters that we specify. Cool. So after executing this step, let me do one thing. We are implementing a simple regression. So here I'll be specifying the train set data split test underscore split, and over here if I just press Control I, you can see the functionality, basically the description of this in the help section. So over here in the parameters, if you see, we need the arrays and we need the test size or the train size on the random state and the random state. Always remember that you can either specify the test size or the train size, because if you specify the train size, suppose if you are having 100% or 100 records and you want to specify that from that 100 records you need around 70 records to be into the train data set. So you just need to specify 0.7% over here, and the remaining will be actually the test size. So any one of the parameters you can specify in this case, either test underscore size or train underscore size. Okay, the first parameter is arrays. So just put it as x comma y. So these are the two arrays that you are actually requiring, because x is the independent and y is the dependent variable. Now over here for this purpose we are going to take it as test underscore size. Now since we have 30 records that I had shown you in the initially, from that 30 records, we'll try to do something like we will be trying to take as 20 values in the training set and 10 values, around 10 values in the test set. So just let me write as 1 by 3. So our test size will basically be 1 by 3. That is 1 by 3 into 30, then 30, the 10 values will be going into the test size basically. Now, the fourth parameter that we are seeing is random underscore state. Random underscore state, I'll explain you what it is basically in the later videos. But currently, you need to understand that random state is a seed value. You can specify it is a seed value. The way it is written, it is a seed value used by a random number generator. So currently, to get the same output, if I'm implementing it to get the correct output as you want to implement it for the parameter, so just specify it as 0. Perfect. Let me just execute it. Okay. Oops, I made a mistake over here. This actually will specify you around four parameters, that is x underscore test, x y underscore train, and y underscore test. So sorry, my mind was not in the right way. What I was thinking. Sometimes this mistakes happens. Now we'll be executing this. Inside this train underscore test underscore split, we have specified x parameter, y parameter, test underscore size parameter, where we have specified the test size as 1 by 3 and random state as 0. So let us execute this and see what we get the output. Fine. So we have got some warnings, but it is okay. Some of my models has got deprecated basically. So let me see in the variable explorer. Now you see, there are four variables that I've created. That is xtrain, xtest, ytrain, and ytest. So if you see from the xtrain, they are specifically around 20 values. Since I had given in my test size as 1 by 3, so remaining 20 will come into our train size. So here is the years of experience that you have, and it is around 20. Similarly, if I go to the x test, in the x test, I have the 10 values which I had specified as 1 by 3. Perfect. I've got my train and test. Let's see y train and y test. In the y train, I can see the salaries, and they are around 20 values over here. So this is perfect. I have my 20 values here. Now, if I go to the Y test, these are the another 10 values that we specified from, we took it from the salary column. Cool. So we have implemented this testing and training set, basically divided the data set into those two forms. Cool. Now let me do one thing. Let me just take the next step, which is implement our classifiers. Implement our classifiers based on simple linear regression. So this four steps, usually for each and every problem you have to do it. You have to read the data set. You need to split the data set based on independent and dependent variables, and divide the complete data set into training and test data set. So just let me give as done. This is done. This is done. And this is done. And finally, this is also done. Okay, cool. This is where we are doing, and now the fifth step, implement our classifier based on simple linear regression. Now, in order to do it, I'll just write a comment over here, implement our classifier based on simple linear regression. Perfect. Perfect. We need to again take sklearn dot. We have something called as pre-processing. Import. No, not this. Sorry, I just got mistaken again. I have called as linear model, and I'll import the linear regression package basically. So from the sklearn.linear underscore model, we'll be importing the linear regression package. So if you want to see this, then the next step basically is defining my simple linear regression classifier. Simple linear regression classifier. Now in this linear regression, why we are actually adding this, this linear regression is doing, this package is basically calculating the beta zero that we had the formula y is equal to mx plus c, which I later converted that into, shown in a different representation format in my previous video, like y is equal to beta naught, which let me write down over here. So we had something as y is equal to beta 0 plus, oops, beta 0 plus beta 1 into y. So here we know that beta 0 is the intercept point, beta 1 is the slope, and beta 1 formula we had discussed in our previous class, which is summation of x whole square. I just don't remember the formula. Let me just specify this. This is how we have calculated beta 1, where summation of xy into summation of x minus summation of x into summation of y divided by summation of x square minus summation of whole square. So this is what the method it is following actually to calculate the beta 1. So that all is happening through this package. You don't have to put down your head and write a different functionality for that, where you're calculating the mean and trying to find out all these things. So instead, you can directly import this package and use it. So I'll just do this linear regression and I'll see if there is any parameters that is read. Okay, for currently, these are the default optional parameters that are required. Currently, we are not doing anything. We are just trying to implement a simple version of simple linear regression. So we'll not specify any parameters. Perfect. Now on the next line, what we will do is we will simple linear regression. We will try to fit basically we will be fitting the x train underscore. If you just go to the fit functionality over here, we can see that there is an x array that is provided over there and an y array, which is the dependent variables. So what I'm going to do, I'm going to provide whatever parameters that we are requiring basically to create. Since we are creating the some classifier based on the training data set, I'll specify all these stuffs and we'll be implementing those classifier. So the parameter over here basically is the X array and the Y array, basically the data set that you want to be using for creating your model. So currently I'm using my trained data set for creating my model. So let me just execute this. It has got executed successfully. You can see over here it's copy underscore x is equal to true, fit intercept true, and job is equal to 1, and normalize is equal to false. So these are the default values and the parameters that are taken for that if you don't specify anything. Perfect. Now, if I go over here, so let me just take one example where I will actually, my classifier is ready. Now I'll try to predict the values based on, we are going to basically predict the values. So, uh, simple linear regression, I'm going to call a predict functionality. In the predict, I need to specify on which test set I need to specify it. I need to predict the values. So the test set is our x underscore test. Just let me enter this. Perfect. I have got the predict value. I'll show you the comparison, how this will be done. So for the x test, we definitely had the value initially as y test. Now this is my very predict. Now you can compare over here and you can just determine like how good is your classifier and whether it is being able to predict your values or not. So the first value, let us compare. It is something near around 37,731. Now here it is 4835, somewhat near. That's okay. You have got some amount of percentage correct on it. Oh, this is pretty cool because it is very, very near to this particular value that we have predicted. Similarly for all the other values. So we have small, small differences, and this one also is pretty good. The seventh row, no, it's not that good, but the sixth row is pretty good again. Mm, similar idea. The third one is the best, I guess, because there's just some values that have got changed in here. So our model looks to be a very good one and it has predicted properly. Perfect. Now, if you want to predict some other values which are not already present over in the data set, basically. So I'll do one thing. Y underscore predict underscore some val. So I want to know from the data set that what will be the salary of if a person is experienced of around 11 years. Suppose, the last value is 10.5. I'll just calculate with the 11 years. So I will do just 11 and I'll try to predict it. So what I see is 11 years is around 12,962. So this is the value for the 11 years of experience. If a guy is of 11 years of experience, this much money he'll be getting. Perfect. We are able to predict it properly. Now, the next thing is how do we see the linear regression? Simple linear regression in the graph. We need to see like in my previous class I showed you like there are some points that are scattered in the graph, and we'll be plotting a straight line which is the best plane which is the best fit line which passes through this point. So let us implement it. Now the sixth step over here is we need to implement the graph for simple linear regression. Perfect. Let's do it. We're going to implement the graph. Okay, first of all, we have imported the package of matplotlib, the pyplot, which is actually being used for the graphic purpose. So next thing is that we do is pyplot plot plus scatter. We have a functionality called as scatter, where we'll be scattering our train set and the train set which will be present through the x underscore train and y underscore train. Perfect. Now, after scattering the x train and the y train, that are the points that will be visible. Just let me write one more thing over here as I'll just specify color and it will be as a red. Now, after scattering those data, the next thing that we'll be doing, we'll be plotting our best fit line through across that particular point. So if I do like plot dot, I have a point called as plot dot. Let me just check. Oh, sorry, plot. So there'll be something called as plot, and in this plot, we are actually going to put our x train based on the x train and the predicted value of the x train. So always remember the best fit line will be, in this case, will be actually created from the model that we are creating. In the model, we have specified x train and y train. So we'll try to predict the x train values and we'll try to plot the best fit line. Cool. So I'll just copy this. So here we are actually predicting, but we have to predict based on the X train. Perfect. So this is my plotting the best fit line over there, which passes through the scattered points of X train and Y train. Now, the next thing that I have to do is I have to show the plot. Simple. Now let me see whether the graph is well created or not. I press Control Enter. I see something here. Whoa, perfect. This graph looks awesome, awesome, awesome. These are the scattered points which we have actually scattered of the X train and the Y train side basically. And on the X train values, we have actually predicted a best fit line, which looks pretty good. So this is basically a simple linear regression. Still, if you want to practice some more from the Kaggle, you can find lot of data sets and lot of scenarios where you do a lot of stuffs where you find different kind of dependent variables and independent variables, and based on that you predict the best fit line. So this looks pretty good. I think this looks awesome because you have predicted a very good thing. Now, if I calculate for the 11 years, still the point will be coming somewhere over here, and this is how the simple linear regression will be done. So, yeah, that's it for the simple linear regression. In the next class, we'll be doing the multiple simple linear regression. So, till then, have fun, enjoy the class, practice some more, and do well. Thank you.